Is it okay if I record this one with you guys? Yeah? Okay, good. So you guys be nice for it. Today is the third and final way that we're going to learn how to solve systems. And that way is by this word right here. The word is called elimination. So we're going to be eliminating one of the variables to get the other one. And this is actually my favorite way to solve systems of equations. All right? This is my favorite way. So we're going to start off with a couple of examples, and then I'm going to ask you for the process. All right? A couple of examples, then I'm going to ask you for the process. And here's the first example. It's going to do this. The first equation in the system says, oops, sorry, not that. It says x plus 5y equals 9. That's the first one. Go ahead, write that part down. X plus 5y equals 9. That's our first linear equation in our system. Our second equation is going to be this. 4x minus 5y is going to equal negative 14. Okay, let's write these two down. Make sure the person sitting next to you has both of these written down before we begin. Everybody got them down? Okay, everybody's got it. Good. I want to ask you a few questions about this. Here it is. Do you notice that before we can go on, I have to ask you, remind you, what does it mean for something to be like terms?
They have the same variable and or exponent.
He is on track here. There's two things that has to happen in order for like terms to be considered like terms. And the first one is they have to have the same, what was it, Ross? Variable. You got it, man. They have to have the same variable and they have to have the same exponent. They have to have both. Exponent. So, let me ask you a question. Do you see any like terms anywhere over here? Yeah, x, right? I want to show you something. I'm going to draw little lines here. I'm going to actually extend this line a little bit lower here. All right? And here's what I want to show you. Do you notice that in the x column, right, everything is lined up vertically? How there's the blue x, and then there's the red 4x, and they're lined up vertically. Do you see that? Yeah. That's actually very, very helpful. And do you see the y's, the 5y, and then the negative 5y, they're lined up vertically? Yeah. And then do you see the numbers, the 9 and the negative 14, right? Yeah. Okay, well, here's what I'd like you to do. I'd like you to add these two things vertically. All right? I'd like you to add these two things vertically. So let's do it together. How much is x plus 4x? 5x. That's 5x. You are correct. How much is positive 5y take away 5y? 0. 0y, yeah, exactly. And how much is 9 plus a negative 14? 5. Negative 5. Okay, negative 5. All right, do you guys notice something? The y variable has been eliminated. It's gone. It's no longer there. It's been eliminated. Oh, you guys catch that? Yeah. So, 5x has to equal negative 5. Oh my gosh, look at that. All of a sudden, now we have an equation that only has one variable. 5x equals negative 5. I just wrote down what I had from before. How do I solve this last linear bit to get to divide by 5? You guys are on the right track. So, x has to be how much? That's tomorrow. That's tomorrow. Today is the basic ones, okay? All right, so now that we know that x is equal to negative 1, are we done with the problem? No, because we know the answer to the problem is always going to x, comma, y. So we figured out that the x coordinate is the negative 1. So what do we still need to do, you guys? Figure out the y. And how are we going to do that? We're going to substitute a negative 1 for x right there. So it says negative 1 plus 5y equals 9. So 5y has to be 10. So y has to be 2. Wait. Oh, I'll do somebody off on that one? Okay, so all I did was I plugged in a negative 1 for x. Said negative 1 plus 5y equals 9 from this linear equation right here, correct? Then I added 1 to both sides and got that 5y was equal to 10, and then I divided both by 5. Does that make sense? Yeah. Yeah, so with me on that part? Okay. How to get negative 1? I got that negative 1 for x. And then because that's x right here. All right? So we agree. We agree now that we think that the answer to this system is negative 1 comma 2. You guys agree with that? Okay, so help me out here. What was the very first equation we had? Wow, you guys are good. X plus 5y equals 9. Is that true? What was the second one? Equals negative 14. So if we graph these two things, what should we expect to see on the graph? Negative 1 comma 2. What's so important about that point? That's where they cross. Let's see. If we're right, we'll see if we get it right here. Is that the point negative 1 comma 2? What do you guys think? Is that the point negative 1 comma 2? I'll zoom in a little bit more. All right. That means that point right there, negative 1 comma 2, clearly matches up with the point that we found. And we solved it by elimination, though. We checked it by graphing. What do you guys think? Pretty good? Yep. All right, good. Let's do another one. Remember, I do have 4 boxes with you today. And I took a lot of time on the first one to sort of set the scene, set the stage, and now we're going to practice. Okay? But I want you to be thinking about the process that we're doing because I'm going to ask you for that process. Okay? Same directions. Solve by elimination. All right, here are the systems here. I got 3x minus 4y is equal to 2. And the other one is 3x plus 2y is equal to 26. Okay, first things first. Are the x's lined up in vertical alignment? Yes. Are the y's lined up in vertical alignment? Yes, they are. But there's something else going on here, isn't there? Times 2. Well, there's something easier to do.
Get rid of the 3x.
We should get rid of the 3x. How do we get rid of the 3x? By subtracting them. Very good. Yeah, we can just subtract here. Instead of adding, we can also subtract, right? Yeah, right. So let's subtract them, and let's do it very carefully. How much is 3x minus 3x? 0. That goes away. How much is negative 4y minus 2y? Negative 6y. Very good. Yeah, we have to make sure we add correctly. Negative 4 minus 2 is negative 6. Okay, what's 2 minus 26? Negative 24, right? If you have $2 and you spend 26, then you're in the hole, $24. Okay, you're negative money, right? It's called the credit cards. Don't get one. All right, negative 6y equals negative 24. That's the truth. So we're going to divide by negative 6 on both sides. So y has to be how much? Positive 4. Very good. Very positive 4. Now remember, the answer is an x and a y. Which part did we find? We found the y. Y was 4. Are we done with the problem? No. Renee, you paying attention, buddy? Okay, what do I do now, Renee? Very good, my friend. I substitute the 4 for the y. Substitute 4 right there for the y. And we solve together. Here we go. 3x minus 4 times 4 is equal to 2. Therefore, 3x minus, how much is 4 times 4? 16 is equal to 2. How do I solve this problem? Zach, what do I do now, buddy? No. What do I do now? Yes. Anna. Add 16. Zach, pay attention, please. So 3x is equal to 16 and 2. How much is that, Zach? Good. Zach, last question. I want to solve for x. What do I do? Yes, now you're back on track, buddy. Thank you. So x is equal to, how much is 18 divided by 3? 6. All right, so what do we agree the answer is? 6 comma 4. All right, we're going to check this now. Let's go check it. What was the original equation? 3x minus 4y equals how much? Equals 2. Okay, notice how the graph's all changing every time I do that, right? Okay, what's the bottom equation? 3x. Let's make that a 3. Okay, 3x plus 2y. 2y equals 26. All right, here we go. There we go. Hey, where do those two lines cross? 6, 4. That's the solution to our system. We go back over here. What was our answer? 6, 4. Did we do it right? We did it right. Okay, here's what I'd like you to do for the third box. It's a quiet box. You're going to do this on your own. Then you're going to share with your friends. And then we're going to talk about it as a class. Here's what I'd like you to do for a quiet box. I want you to come up with a process. Come up with your own process for solving systems by elimination. And I'm going to challenge you to keep it to 3 steps. 3 steps, but you can use more than one word for each step. Think about what we did in the past 2 problems. The first problem and the second problem to solve by elimination. What did we do first? What did we do second? What did we do third? I want you to think about your own process. I want you to come up with your own process. We'll talk about it, and then we will test that process for the last box. Do you understand what I'm asking you to do? No. As a discussion? Okay, well, great. Here's what we have so far. These are really good. I'm glad that you guys came up with these. This is awesome. Your process should be line up, vertical, eliminate, then solve. And the other one said eliminate, solve, and substitute. So what I'm going to do is I'm going to combine these 2 for you guys. This is pretty good. I like the line up. Okay. We're going to line up vertically. I like that. We're going to eliminate and solve, and then we're going to substitute. Okay, eliminate and solve, and then we're going to substitute. So that's going to be our process here that you guys came up with, and I just sort of simplified it, put it into one. Nice job. You guys came up with this one all by yourself. Very good work. And this one all by yourself. I like that. All right. I want to point something out to you guys. I'm so glad that you guys came up with line up vertically because, look, I just threw this one at you. And if you guys didn't have that very first step in the process to line up vertically, then we'd be stuck. So I am super excited and glad that you guys come up with this process all by yourself. So we're going to line up vertically first. Yes, that's part of the process that you guys created. Line up vertically. That's what we're going to do. So we're going to say 6x plus 7y equals 16. Now, how do I line up vertically if I want all of my x's in a row? Yes, sir. You got it. So negative 6x plus y is now equal to negative 32. So now, are all my x's lined up? Are all my y's lined up? Yeah, so now I'm good to go. Okay, should I add these 2 together or should I subtract these 2 together? We should add them. Yes, exactly. How much is 6x plus a negative 6x? 0. That goes away. How much is 7y plus 8? I mean, shoot. 7y plus 1y is 8y. You guys got it. And how much is 16 plus a negative 32? Negative 16. So there it is. We see y. 8y equals negative 16. What do I do now? Divide by 2? You mean the answer is going to be negative 2. Okay. So here's x and here's y. We got an answer of negative 2 for y. Are we done? No. What do we do now? Well, let's consult the process. We lined up. We eliminated. We solved it. Do what now? Substitute. Let's do it. So we're going to substitute negative 2 for y. So I'm going to substitute this right here. So I get this. 6x plus 7 times negative 2 equals 16. So 6x minus 14 equals 16. What do I do now? Add. Good. 6x equals how much? 5? No. 30. Very good. Divide by. So x equals how much? All right. So we think now the answer that we've earned is 5, negative 2. We think that's the answer to the system. So we're going to check that answer really quickly. What was that first equation we had? 6x plus 7y equals 16. What's the other one? 6x minus how much? All right, so when we graph these, we should see what point should they meet at. What number is this? 5, negative 2. Is that what we got over here? Okay, for the very last part of the day, we're going to write down the process for each of the 3 methods of solving systems of equations. Each one should have 3 steps. We've already figured out the elimination one today. So please spend the next 3 or 4 minutes and write down all of the process for graphing each of these. So this is what we came out at the end here. For graphing, we're going to graph it, check the intercepts, and then check to see if we did it right. For substitution, we're going to isolate a variable, substitute, then plug back in. And for elimination, we're going to line up vertically, eliminate and solve, and then substitute. Nice job, you guys.